Okay, so we'll be solving one problem from GATE 2023. Okay, and we'll be using Norton's theorem and Thevenin equivalent for that to solve the circuit. Right now, of course, using KCL KVL you can solve this circuit. So basically, they are asking to calculate the current here. Okay, but that will consume too much time. So what we're going to do is use this trick. Basically, not trick. This is theorem from Norton and then Thevenin equivalent to simplify the circuit. First of all, so we know this is called as Thevenin equivalent, and its corresponding Norton equivalent is this of a circuit this part of the circuit. So if you have voltage VTH, okay, and resistance R, you can write it this resistance in parallel to a current source, which will now be equal to VTH by R. Okay, similarly, you can go from this to this, where you make this resistance in series here, and the voltage will be I into R. And so we'll be using this trick here. So what we can do, first of all, let's solve this circuit part-wise. So let's disconnect this part and solve it separately, right? So this part we can solve it separately. This part will solve it separately. So when current is in parallel to this, right? So this is not an equivalent. So we can convert, and this is the Thevenin equivalent. First of all, let's convert this to this form, right? So if you convert this to this form, the resistance in series will come in parallel. So if it comes in parallel, it will be like this, right? And this will become now current source. 2 by 2 is, now it will become 1 milliampere, right? Now you see how much we have simplified this part of the circuit. Now there are two current sources in parallel, two resistance in parallel, right? So two resistance in parallel will become, so 2 into 2 kilo ohm by 4, right? Basically it becomes 1 kilo ohm. So this will be 1 kilo ohm resistance. And let's add these two also, so this becomes 2 milliampere current source. So we can move this now, right? Very much simplified. Again, now solving this one, right? We can convert it to this form. It becomes a voltage becomes. So how to solve this first? Okay, so this is the current, and the potential drop across this will be what? 1 volt, because 1 milliampere into 1 kilo ohm. So we'll replace it with a 1 volt source, right? Because the drop was across this direction, right? Plus minus, so same direction the potential source is added, right? Voltage source is added. Now we have simplified this as well. We can further simplify this, right? We can make it in this form, Thevenin form. 2 into 1 ampere will be 1 volt, 2 volt, and then 1 kilo ohm will come in series. So 2 volt, 1 kilo ohm will come in series. Okay, now just connect it all of these back, right? Now see how much we have simplified. Now calculating current is very easy. It's just the total voltage source, which is 2 volt, 1 volt, 3 volt. Total resistance 2 kilo ohm plus 0.2 kilo ohm, 2.2 kilo. And if you solve this, it will come around like 1.36 milliampere. So that's the solution for this. So we didn't have to write any equation to solve this circuit, right? If you do this mentally, you can do this even faster, right? Just to show you, I had to go through all these steps.